Hello, and welcome to today's session. As always, I'm your host, Kevin Grote, Staff Systems Engineer here at VMware. Today we're going to be talking more about virtual SAN. Now, I know what you're going to say. Kevin, we've already heard tons about vSAN. But wait, there's more. We're going to be talking today about the next dot release in virtual SAN 6.2. Now, I always make sure to remind everyone that a dot release is really just about features. So I can only imagine with what's in 6.2, what's going to happen when we have our next major release. It's going to be huge. So today we're going to double click into a couple key concepts that are really top of mind when we look at virtual SAN 6.2. And those are deduplication and compression, as well as erasure coding. So whether or not you're familiar with those concepts, hopefully by the end of today's session, you'll have a really good idea of how to position those, what they mean inside of your customer space, and how important they can be to your infrastructure decisions going forward. So without any further ado, let's take a deeper look at virtual SAN 6.2. So let's go ahead now and double click into what's new with virtual SAN 6.2. And you'll notice here that on the slide it says hyper-converged software and virtual SAN 6.2. And I think this is something that's often kind of forgotten, is the fact that virtual SAN really is truly hyper-converged infrastructure. I mean, you have a convergence of different types of infrastructure, and virtual SAN is a clear representation and utilization of that. VMware fundamentally believes that hyper-converged infrastructure is software-driven architecture, not limited to just one specific deployment model or hardware-locked configuration. HCI is about leveraging two fundamental components inside of virtual SAN: hyper-converged software and industry-standard hardware, so that there's a lot of flexibility. And this allows hyper-converged software to stay flexible, to be able to deliver compute, storage, networking, and management from a very tightly integrated stack. It allows the convergence of physical storage onto industry standard x86, which gives us the clear ability to set up a building block approach with scale out capability and very granular growth. So this is important and central to the concept and what we're doing with virtual SAN, as really as well as the rest of the software-defined stack. This gives us that core building block for the software-defined data center by adding additional capabilities like NSX for network virtualization. And if you're not familiar with NSX and microsegmentation, be sure to check out the other videos inside of this playlist. And also advanced management with vRealize, so that we can take that and layer it on top. This gives us the complete software-defined data center solution, because at that point we're leveraging industry standard servers that we can grow granularly and also be able to maintain choice and freedom of flexibility over, to be able to snap in hyper-converged software, everything from vCenter server, Vsphere, virtual SAN, NSX, and then to be able to layer on SDD software with vRealize operations, log insight, and then we can attach Horizon for virtual and hosted desktops above that. So we really have a data center that is completely built and realized within software and convergence. So coming back to virtual SAN. So virtual SAN, for those of you that are not aware, is VMware's software-defined storage solution. So it's really built from the ground up for vSphere virtual machines. In fact, when you talk about read-intensive workloads, things like cloud-based workloads or VDI, virtual SAN is really purpose-built for the new era of what's next. And effectively, virtual SAN allows us to commoditize the localized storage that exists on individual physical boxes and turn them into a virtual SAN data store. So we can do this and pool all that together on any standard x86 server. And then we can manage virtual SAN through per virtual machine storage policies and then integrate it very deeply and tightly into the rest of the VMware stack. So what are we doing inside of virtual SAN 6.2? Well, with all the major enhancements of this release, virtual SAN is bringing enterprise-class scale and performance, as well as new capabilities that really broaden the applicability of the now proven virtual SAN technology that everybody has been, raving about for so long. vSAN is built ground up for the virtual infrastructure. It's simple to deploy, highly performant, highly scalable. Like we said, can be scaled in as granular a way as you want to. And because of that, it leverages high levels of cost savings. vSAN is really best suited to be the storage for all of your virtual machine workloads. And let's remember that you can still leverage virtual SAN alongside your existing storage, maybe for test dev or staging or remote or branch offices or end user computing. It's a very organic position for virtual SAN. Virtual SAN, as of the last versions, are really now completely enterprise ready for tier 1 production applications and business critical apps. There are really two flavors for virtual SAN. Virtual SAN enables both hybrid and all-flash architectures. So irrespective of the architecture, there is a flash-based caching tier, which is used for read caching and write buffering into the hybrid tier if that's the case, which allows it to be, again, highly performant, especially when you're talking about read and read intensive I/O workloads, things like cloud or VDI. And so in all flash, the flash-based caching tier is intelligently used as a write buffer only and for the read cache, while another set of SSDs forms the persistence tier to store the data, which is going to be very similar to the hybrid. It's just that we're leveraging the all-flash write cache, and then we're leveraging the SSDs below it, where in hybrid, we were leveraging the read and write cache inside of the SSD, and then using the spinning disks for the capacity tier. Then you can also see that inside of all-flash versus hybrid, we also have over 2x the number of IOPS per host, plus sub-millisecond latency inside of all flash. So what's new? And we're going to focus on just a couple of the things that are new inside of 6.2. If you would, the greatest hits so far. One is deduplication and compression. Now, keep in mind, this is for all flash only. So dedupe and compression happens during destaging from the caching tier to the capacity tier. Okay, so we remembered in the previous slide we saw that inside of all flash we're going to use that the SSDs inside of the caching tier for the write buffer only, and then it's all going to be moved down into the SSDs for data retention. So you enable space efficiency on a cluster level, and the dedupe happens on a per disk group basis. And remember, we can have multiple disk groups on an individual host. Bigger disk groups result in a higher deduplication ratio. After the blocks are deduped, they will be compressed. A significant savings happens already, and then combine that with deduplication, and the results achieved can be much greater. Of course, fully dependent on the workload and the type of VM, so mileage is going to vary, but it gives you kind of a high-level understanding of it. Now, if we look beyond deduplication and compression and the savings that that's bringing you, we also have inside of all flash RAID 5 and RAID 6 erasure coding. So Sometimes RAID 5 and RAID 6 over the network could also be referred to as erasure coding. In this case, RAID 5 requires 4 hosts at a minimum since it's going to use a 3+1 logic. With 4 hosts, one can fail without any data loss. This results in a significant reduction of required disk capacity because you're going to be spreading it out across a significantly larger number of hosts. Normally, a 20 gig disk would require 40 gigs of disk capacity, but in the case of RAID 5 over the network, the requirement is only about 27 gigs. There's another option if higher availability is desired. So this is completely configurable through the VM storage policies, and you do this through defining the fault tolerance method, and we'll show you here in a second, or FTM. When you configure this, you have 2 options. RAID 1, which is mirroring, and RAID 5.6, which is erasure coding. Depending on how many failures to tolerate, or FTT, is configured when RAID 5.6 is selected, you will end up with a 3+1 for RAID 5 configuration for FTT and a 4+2 for a RAID 6 configuration, and that will give you faults to tolerate of 2. So really, the RAID 5, RAID 6 selection is going to be the same in setup, but depending upon how many hosts exist, it's going to treat it differently. And you can see here that this is where you're going to set up your erasure coding. And in this case, we have numbers of failures to tolerate of 2 and a fault tolerance method of RAID 5.6 erasure coding. So this is going to mean that this is going to set up this storage policy as RAID 6. And then we can see the RAID 6 erasure coding, and we can monitor it right inside of Vsphere, and we can see that it's compliant, and we can also see all of the disks and the physical disk placement as well as capacity, and we can also bubble this information into things like vRealize operations. Another one that I thought might kind of go unnoticed, but I wanted to bring up, was virtual SAN quality of service. So this enables per VMDK IOPS limits. So they can be deployed by SPBM, so you can tie them to existing policy frameworks. This allows service providers to create differentiated service offerings using the exact same cluster and pool of storage. So no longer do you have to have, well, this is my cheap storage, this is my expensive storage. You can do it all inside of the same storage, but you can deploy it by policy. So you've got kind of a one-click to configure limit, where you can set up the IOPS limit for specific objects that get attached to that storage policy. This is when we are talking about vSAN really being completely and perfectly suited for virtual infrastructure. This is just another shining example of that, at least for me. We also have enhanced SAN management for vSAN with the new health service. Performance monitoring allows from vCenter to be able to monitor all of the existing workloads. So customers needing access to tactical performance information will not need to go into vRealize operations. Now, they will be able to see even more inside of vRealize ops, but they're going to now be able to see performance and capacity monitoring, the same types of dashboards that they'd have inside of ops, they can see directly inside of the Vsphere web client without having to migrate off into another pane. And so because of that, this gives us more flexibility to do things like bicameral management, whether it's from log files to storage to networking to compute, and to be able to provide the admin kind of the day-to-day view into what's going on. So how do you get started with virtual SAN? Well, number one, be sure to check out the hands-on labs, and you can go to vmware.com/go/try vSAN-en. You can also download an evaluation. The same place. You can get a 60-day free virtual SAN eval. And remember, if you're a VMUG member, you get a 6-month evaluation or 1-year eval experience for just $200. And then number 3, and this is a big one, is to conduct a vSAN assessment. So after you've played with it and after you've downloaded the eval, be sure to reach out to your partner teams and VMware folks to conduct a vSAN assessment. And you can get results in as little as 1 week to determine the viability based upon your existing vSphere storage environment to determine some technical and business recommendations for how you can place vSAN inside of your space. Thanks again for taking time with me today. Hopefully you found this information valuable as always. I look forward to talking to you again soon, and until then, be sure to reach out to your local engineering and sales teams for more information on these fantastic products and so much more. And be sure to check out the playlists here for more content regarding end-user compute, software-defined data center, mobility, storage, and software-defined networking, and more. And also, be sure to follow me on Twitter for more updates. Thanks again, have a fantastic day, and I look forward to talking to you again really soon.